Okay, so anyone who'd like to remind me what we did equation of tangent. So can anyone summarize what we do in order to find out the equation of tangent in simple steps? All right, don't make it too complicated.
So first find the dy on dx, and then we have to put the we have to get the gradient, and after that we have.
How do we get the gradient? How do we get the gradient?
By doing the differentiation.
No, differentiating. After we differentiate, we get.
Putting the x value into the differentiated equation.
Okay, carry on.
And then we'll put the x values in the original equation.
That gives us the y coordinate.
Yes.
Okay, and yeah, then we have what we need in order to form an equation. Okay, good job. Acha, so how is normal different from tangent? What is the one thing we do differently if we're talking about the equation of tangent? The reciprocal, just reciprocal? Yeah, -1 upon m. Okay, so yeah. Okay, so today what we'll do is we will inshallah do some questions. Okay, we'll do some questions from the book and we'll do some questions from past papers as well. Okay, so that way, the thing about differentiation is that because you have a lot of small concepts, so if we do past paper questions on the side, then we won't have to do past paper questions in the end. Okay, so we'll do past paper questions alongside. So when we do stationary value, we'll do some past paper questions related to that. Now that we've done the equation of tangent and normal, we'll do some past paper questions related to those. Okay. So here's a question. This is not a past paper question. It's a question from the book, but let's see what it says. So it says the equation of a curve so and so. Show that the equation of the normal to the curve at the point -2, 3 is so and so. Find the coordinates of the point at which the normal meets the curve again. Okay, so we'll worry about part B later. First, let's get through part A. Okay, so with differentiation, please note that the working is very lengthy. So make sure that you do it step by step, right? Don't do it in a haphazard manner. Just do some planning before you start. So we need to find out the equation of the normal at the point so and so. So we have the x coordinate and we already have the y coordinates. That means we don't do the step where we plug in the x coordinate back into the equation. We already have the y coordinate, like I said. So we're going to find out the gradient by differentiating it, plugging in the x value. Then we'll have to take the negative reciprocal. That way we'll have the gradient of the normal. Then using the gradient and the point, we will form an equation. Okay, so it's always a good idea to plan ahead. Complete square? Okay, why exactly will we do completing square? Just because it's a quadratic equation doesn't mean that we have to do completing square. What's the purpose of doing completing square? What's the objective? To get turning point. Do we need the turning point here? No, we don't. So we're not going to do completing square. Okay. So y is equals to 5 minus 3x minus 2x square. No, you didn't miss anything. Then we differentiate. So dy by dx is equals to -3 minus 4x. All right. Now let's plug in x equals to -2. So when x equals to -2, dy by dx equals -3 minus 4 into -2. So that's going to be -3 plus 8, which means it's +5. So the gradient of the tangent is 5. That means the gradient of the normal is going to be -1 upon 5. Okay. And the point, we already have that. That's -2, 3. Now, this is what we're going to use. Y minus y1 equals to m into x minus x1. Minus minus becomes plus. So cross multiply. We have 5y, sorry, not 2y. 5y minus 15 equals to minus x plus 2. So 5y equals to negative x plus, no, wait a minute, negative x minus 2. -2 plus 15, so that's 13. And let's write it the way the question wants us to write it. So that's x plus 5y equals to 13. So fairly easy question, not at all nothing complicated at all. But let me know if you have any questions. Yeah.
Sir, I have a question that we're given x and y coordinates. So, is there any, did we make use of y coordinate to find out the gradient?
No.
Only the gradient.
The gradient is always dependent on the x coordinate. Okay?
Okay, sir.
The gradient is always dependent because they're gonna think about it. When you differentiate, you get dy by dx. Dy by dx is in terms of what? This expression. This has what it's in terms of x. So there is no dependency. I mean, it's not dependent on the y coordinate. It's possible that you may just be given the y coordinate, which means now you need to plug in the y coordinate to find the x coordinate. But ultimately, what you need is the x coordinate, okay, as far as finding the gradient is concerned. Okay? Now, part B. Read part B and tell me what comes to mind. Simultaneous equation. Okay, that is correct. Now, I want you guys to understand what it is that we're doing, okay? And for that, we're going to refer to Desmos, as always. Okay.
So were we done with the differentiation?
What do you mean? Were we done with differentiation?
Like we're doing the questions, so I thought we're done.
We're not done with all the concepts. We're done with all the concepts as far as equation of tangent and normal are concerned. Okay. We're not done with all of differentiation. Obviously, we have stationary value left. We have maximum, minimum value left. So that is left. 5 minus 3x minus 2x squared. Okay, so this is the curve. All right, this is the curve in question. Now, we know that there is a tangent line. Sorry, there is a normal line, which is x plus 5y equals to 13. Okay, and what did we find? We found out the equation of normal from this point, minus 2 comma 3. Now, you can see that this is one point, the point where this line is normal to the curve, okay? Now, when we extend this line, you can see that this normal line is meeting the curve again. Okay, now how will I find out this point of intersection? Whenever you have to find out the point of intersection, what do? We solve the two equations simultaneously. Okay, now the reason why we're doing this, you may be wondering, is to understand what it is that we're doing. Okay, so you know one point where the line and the curve are intersecting. Okay, that is the point. We call this the point of tangency. In this case, the normal line. Yes, the blue line is the normal line. Okay, now this is the point where the first meet. Now if you extend this line meets the curve again. This is what we need to find. These are the coordinates that we have to find. And how do we do that? How do you find the point of intersection? Irrespective. You find the point of intersection by solving simultaneously. Okay, so we have x plus 5y. One equation is just a second. Yeah. So we have x plus 5y equals to 13. And we have another equation, y equals to 5 minus 3x minus 2x squared. Isn't the normal supposed to be perpendicular to the tangent? Yes, it's supposed to be perpendicular to the tangent, which is why we took the negative reciprocal of the gradient.
Sir, so it wasn't perpendicular in the graph that you showed.
It was. Reason why you can't tell is because you can't see the tangent line. Okay, that's why you can't tell. Reason why you can't tell whether it's perpendicular is because the normal is perpendicular to the tangent. So if I draw a tangent at this point, then this blue line is going to be perpendicular to it.
Sir, so when we say that something like this line is normal to the tangent of the curve.
Yeah. Yeah. Because a 90-degree angle is, any angle is formed between two what? Complete the sentence. Any angle, doesn't matter whether it's 90 degrees, 60 degrees, is formed between two what? Two lines. Okay, so you can't have an angle between a line and a curve. So when we say normal to the curve, what we mean is that normal to a specific point where tangent is drawn on the curve. So if I say this line is normal to the curve, that does not mean it's making a 90-degree angle with the curve. This means that this is a line which is perpendicular to a certain point where tangent is drawn. That's what we mean. Okay? Clear up?
Yes.
Okay. Acha, now coming back. So we need to find out the point of intersection, which means we need to solve them simultaneously. Okay. Now, how do we solve them simultaneously? The only method that we can use is substitution. I'm thinking of an easy way out, but sadly there isn't one. So we'll have to take the longer route, which means we need to first make y the subject. So 5y equals to 13 minus x. Y is equals to 13 minus x upon 5. Now we equate the two. 13 minus x upon 5 is equals to 5 minus 3x minus 2x square. Let's cross multiply. So 13 minus x equals to 25 minus 15x minus 10x square. Let's get all the terms on the left hand side. So 10x square. Achha, I'm going to skip a few steps. I'll simplify at the same time. Minus x plus 15x, it's going to be positive 14x. 13 minus 25 is going to be negative 12, but to be on the safe side, yeah, negative 12 equals to 0. So we can take 2 common, we can divide the entire equation by 2 and then solve, or you can apply the quadratic formula right away. I'm just going to apply the quadratic formula right away. In fact, I'm just going to use my calculator right away. And we have one value of x, which is 0.6, and the other value of x is minus 2. Now, which value of x are we going to use to find the y coordinate? Keep your eyes and ears open. Read the question carefully before you answer. Don't jump to conclusions. Tell me. Which value of x, y 0.6? And anyone who disagrees with that, please go ahead. Okay, 0.6. Why? Why not minus 2? That is correct, because minus 2 is the point we can see already. It's the point that we have already. It's the point where this is, the line is normal to the curve. Okay? What does the question say? It says find the coordinates of the point where the normal meets the curve again. So obviously we're not going to find out the corresponding y value of minus 2. We already know what it's going to be. It's going to be 3. We want the point where it meets the curve again. So we'll take this 0.6 and y is equal. Okay, what happens if I take minus 2? Put some thought into it. Okay, and just look at the context of the question, Fatma. Look at the context of the question and see if you can find the answer to your own question. Just think about it. Why should we not take minus 2?
Is it because this is negative or something?
No, of course it's not negative. Of course it's not because it's negative. थोड़ा सोचो तो ज़रा दिमाग पे जोर डालो सोचो कि हम क्यों -2 नहीं ले रहे हैं कि हम क्यों 0.6 ले रहे हैं ज़रा क्वेश्चन में देखो क्या दिया हुआ है थोड़ा गौर से देखो ऐसे थोड़ी कि कोई चीज़ फ़ौरन से नहीं समझ आए तो you give up already. Just put some thought into it. Read the first part of the question. Look at the coordinates. What do you observe about the coordinates? Yes, Nahyan.
I can see कि -2 already है.
Exactly. और part B में क्या लिखा हुआ है? Find the coordinates of the point at which. What's the last word in part B?
Normal meets the curve.
The last word. That's not the last word. The last word of part B. Again, exactly. What does that mean? This is the point where it's meeting once. So, will I find out is -2 is x equals to -2 a new point, or it's the point that's already given?
New point.
X equals to -2. Is x equals to -2 the new point, or is it the point that's already given? That's already given. So now you understand why we're not going to use -2? And why we're going to use 0.6? ठीक है? So थोड़ा सोचा करो जैसे नहीं कि कोई चीज़ नहीं समझ आई तो फ़ौरन से give up कर दिया. थोड़ा put some thought into it. When you put some thought into it, you'll end up learning a couple of new things also. Okay, and you know that's what A-level math is all about. If you're going to give up at the first sign of trouble, then I'm afraid A-level math is not for you. Again, this goes for everyone. You have to.
Sir, can you explain part A again?
Okay, I can explain part A. What are the steps that we follow in order to find out the equation of normal? First step, we differentiate. So we get the gradient function. How does this help? This helps us in finding out the gradient at any point. All we need is the x coordinate. So of this point, we have the x coordinate. Can we plug it in? If we plug it in, we get the gradient. But remember, when you plug in the value of x in dy by dx, you get the gradient of tangent. Okay? What you want is the gradient of normal. Normal means it's the perpendicular line. So if you have the gradient of one line, how do you find out the gradient of the line that is perpendicular to it?
Sir, negative reciprocal.
That's what I did. Okay, now ultimately what we're doing is we're finding out the equation of a straight line. What do we need in order to find out the equation of a straight line? We need two things. Remember, there are two boxes we have to check. What are those two boxes?
Y minus y1.
नहीं वो तो format है ना. What are the two things? What are the two things after which we're in a position to do what you're saying? Y minus y1 equals to mx minus x1. If I give you just the gradient and I ask you to find out the equation of a straight line, is that enough information? Yes or no? If I give you just the gradient and I ask you to find out the equation of a straight line, is that enough information? Yes or no?
No, I don't think so.
What else do you need? You're right. It's not. What else do you need?
One more coordinate.
We need a point. देखो एक line की equation कब निकलती है? When you have a gradient and a point. Okay, so after finding out dy by dx, taking the negative reciprocal of it, do we have enough information? I mean, we have the gradient. What do we need? We need a point. Is the point given in the question? Yes, it is. Now, can you put this together and form an equation? Refer to the steps now. Did you copy down the steps?
Yes.
Okay, so everything's there. Plug in x equals to x1 in equation of the curve to find y1. If you remember, I said this is something we already have. Now that you've checked two boxes, you put it together, you form an equation using this. Tangent, if this is what it is, and normal, if you're finding the equation of normal. Okay, all good now?
Yes, thank you.
All right, you're welcome. Acha, I've taken out some questions, some past paper questions, which we are going to solve. And yeah, here is one. It's a 5-mark question. It's a fairly recent question. Let's see what it says. So it says here, the line y equals to ax plus b is a tangent to the curve so and so. At the point 2, 6, find the values of the constants a, b, and c. Okay? So first of all, how do we find out c? We don't have to follow a specific order, but we can find out c. How? Think about it. Turning point? Really? C is the y-intercept. Okay, I agree. It is the y-intercept. So this is an equation. Yes, that's correct, Ryan. Okay, no. That's not what we're going to do. Dekho, here's an equation. How many unknowns do you have in this equation? How many unknowns do we have in this equation? X, y, and c. Is that correct? How many unknowns do we have in this equation? We have 3 unknowns. X, y, and z. If I... Okay. क्या कर रहे हैं आप लोग? कोई कह रहा है turning point, कोई कह रहा है plugging in x equals to 0. Somebody's saying turning point... somebody's saying... क्या? B square minus 4ac. No, none of that is true. Okay? Listen, see what the question is saying and don't jump to conclusions. You have an equation of the curve and you know a point through which the curve is passing. Okay? All you got to do is plug in x and plug in y and solve for c. How difficult is that? I mean, these are the kind of questions that we have in O-levels. Okay? These are the kind of questions that we come across in O-levels. Plug in x, plug in y, and find c. Okay? In fact, that's what you can do with pretty much any equation. If you have an equation which is in terms of x and y, and let's say we add another unknown to it, if you know x and y, you can find out the other unknown. So 6 is equals to 2 into 2 cubed minus 5 into 2 squared minus 3 into 2 plus c. Can we not do this? Is this mathematically wrong? Yes or no? It's not. Okay. Why? Because 2, 6 is not a random point. 2, 6 is a point through which the curve is passing. Okay. So 6 is equals to 16 minus 20 minus 6 plus c. So let's see, what do we have? C is 16. All right. Yeah, C is 16. Okay. Any questions so far? Please feel free to ask. I don't want to get to the end of the question and then somebody's... and then have someone say that I don't understand how you found out C. Achha, somebody said plug in x equals to 0. What happens if I plug in x equals to 0? The question is y is equals to c is what we end up with. Does that solve the problem? No, it doesn't. We still don't have the value of c. Okay? So that's why that's wrong. All right, so now the equation of tangent looks like this. Y is equals to 2x cubed minus 5x squared minus 3x plus 16. Okay? Now, how to find out the equation of tangent? Yes.
Sir, will we get y-intercept if we put x equals to 0?
We will get y equals to c. Okay, y equals to c doesn't really solve for the value of c. We do get y-intercept, but we get y-intercept when you know what the equation is. Like, for example, if let's say you're given y equals to x squared plus 5x plus 3. Here, if I ask you to find out the y-intercept, yes, you're going to plug in x equals to 0 and be able to find out the value of the y-intercept. Here, tell me, if you plug in x equals to 0 with the equation being as it is, will you be able to find out the value of the y-intercept or the value of c for that matter? Yes or no?
I think we'll get y-intercept in terms of c.
Yeah, so will that help us find out the value of c? Yes or no?
No.
It won't. Okay, so I hope that answers your question and clears the confusion as well. Okay, so let's find out the equation of tangent. Okay, what do we do for that? First step, differentiate. So 2 into 3 is 6, 6x squared minus 10x minus 3. What are we going to do now? What are we going to...
Differentiate.
No, I've already done that. I've already differentiated it. Okay, what are we going to do now after differentiating it?
X value.
Okay, so I'm going to plug in x equals to 2 over here. So dy by dx equals to 6 into 2 square minus 10 into 2 minus 3. So 2 square is 4, 4 times 6 is 24, 24 minus 23, that's 1. So dy by dx, or the gradient of tangent, is 1. Now, should I take the negative reciprocal of 1? Why not?
Yes.
Okay, why will I take the negative reciprocal, Fatma?
Sir, because आपको tangent की equation चाहिए थी.
तो हम नेगेटिव रेसिप्रोकल टेंजेंट की इक्वेशन में लेते हैं या नॉर्मल की इक्वेशन में लेते हैं?
But tangent भी तो वो perpendicular होता है ना curve से.
किसने बोला? Tangent is not perpendicular to the curve. This is the tangent. Tangent is the line that is just touching the curve. We take the negative reciprocal when we're finding out equation of normal. Fatma, do your revision, beta. That was just a trick question. I really wasn't expecting you guys to get it wrong. Okay, please do your revision. So the gradient is as it is. Now we need a point through which the curve is passing. 2, 6 is what we are given. Okay, we don't need to plug in the x coordinate to find out the y coordinate. We already have that. So y minus 6 is equals to 1 into x minus 2. So y minus 6 equals to x minus 2. Now let's rearrange it. So we have y equals to x plus 4. Now what's a equal to and what is b equal to? What is a equal to and what is b equal to?
1, 4.
A equals to 1 and b equals to 4. Yeah, a equals to 1 and b equals to 4, Ubaid. Okay, so this was a past paper question. What would you guys say about the difficulty level of this question? Yeah, I would agree that it's probably a 3 or a 4 on 10. These, all right, good to hear that. Now, the thing is, let me tell you guys something about differentiation. If you, let's say, if you've just memorized the steps and you're just brainlessly applying them and not at the same time, you're not aware of what you're doing, then that's not how you can do differentiation. In fact, that's not how you can do calculus at all. No, I don't have a sore throat, but yeah, this is my 3rd or perhaps 4th class of the day. But no, I don't have a sore throat. Thank you for asking. So as I was saying, if you're just brainlessly using formulas and you don't have a clear understanding of why you're doing what you're doing, then I'm afraid you'll only be able to solve a limited number of questions with that approach. You won't be able to solve a lot of questions. So you got to make sure that you understand the reason why we always go the extra mile, so that we understand why we're doing what we're doing. And then once we've done that, we can then memorize, but the understanding should always be there. That's a must. That's non-negotiable. All right, so here's a question. Let's see what we need to do here. The tangent to the curve so-and-so at point A is parallel to the line y equals to 2 minus 3x. Find the equation of the tangent at A. Okay, so keywords in this question. What do you think are the keywords in this question? I'll give you guys a hint. There are two. Okay, parallel, very good. What's the other keyword? Tangent. That is correct. Okay, so the tangent here and the tangent here. Now, what exactly is this question trying to say, and what does it want? Let's look into that. So, the tangent to the curve at point A is parallel to this line. So, what happens when two lines are parallel? What happens when two lines are parallel? Same gradient. Okay. So, technically, what do we know about the tangent? We know what it's parallel to. So, what do we know about the tangent? Think about it.
So the gradient of the straight line will be
Yes.
the same gradient that tangent has.
Yes, that is true. So, here's the equation of the curve y equals to x cubed minus 9x squared plus 24x minus 12. Okay. Now, there is a point A. We don't know the coordinates of point A, but we do know that the gradient of tangent at the point A is the same as the gradient of this line. That means technically we know that the gradient of tangent is minus 3. Yes or no? Do you guys agree with that? Because you have to make sure that you understand this before we do anything else. We now know that the gradient of tangent is minus 3. It's like there are two possibilities. One is the question can give you the x coordinate and ask you to find out the gradient of tangent. The other is the question can give you the gradient of tangent and ask you to find out the x coordinates. All right. Acha, if you think about it, before we do anything else, we need to find out the equation of tangent at A. Remember the two boxes that we have to check in order to find out the equation of any straight line. One is the gradient box and one is the point box. Okay, x comma y. So what is the box that we can check and what is the box that we need to check? We can check the gradient box because we have the gradient. However, what we don't have is the point. Okay, we don't have the point, so we need to find that. Y equals to mx plus c, y equals to minus 3x plus 2. No, wait a minute. No, let's not jump to conclusions. Okay, yes, we can check the gradient box, but we need to find out the point. Okay, so let's differentiate. dy by dx equals to 3x squared minus 18x plus 24. Now, since we already know the gradient of tangent, that means we know dy by dx. So we're going to equate this to minus 3. Okay. Now, let's get all the terms over to the left-hand side. So 3x squared minus 18x plus 27 equals to 0. When I solve this, I get x. What does that x represent? When I solve this equation, I get the value of x. What does that value of x represent? It represents the x coordinate of A. Very good. It represents the x coordinate of A. So that means we are partially checking the point box as well. Okay, we're in a position to partially check the point box as well. Now, we will be able to fully check it once we have the y coordinate. So how do we get the y coordinate? Question for you guys. Yes, we can place the value of x. That's correct. We're going to plug it back into the equation. Y equals to x cubed minus 9x squared plus 24x minus 12. In this, we're going to plug in x equals to 3 so that we have the y coordinate. That means 3 cubed minus 9 into 3 squared plus 24 into 3 minus 12. Okay, let's solve this. See what do we get. Don't make a sign. Don't make a calculation error, please. Otherwise, you lose very important marks. 9 minus 3 squared plus 24 times 3 minus 12. So the y coordinate is 6. Now we have a point. Now we have everything we need. We have the gradient of tangent. That's negative 3. And we have the coordinates of A, 3, 6. That means we can find out the equation y minus 6 equals to minus 3 into x minus 3. So y minus 6 equals to minus 3x plus 9, which means y is equals to minus 3x plus 15 is the final answer. Now, take a good look at it. Let me know if you have any questions. And also let me know What do you think about the difficulty level of this question? Yeah, you already have 50% of the answer. Acha, what if the question said that the tangent is perpendicular to this line? Then what are you going to do? Let's say instead of parallel, yeah. Then before you equate it, yeah, then the gradient would have been not 3, not minus 3. In fact, it would have been 1 upon 3. Okay, so watch out for these keywords. And, this is the max that can happen in questions like these. Okay, this is the max that can happen in questions like these. You just got to be able to read the question carefully and not jump to any conclusions.
Sir, I have a question, please.
Yeah, go ahead.
In the last question, you wrote the x coordinate as negative 3 in this question.
Here?
Oh, no, down, yeah, it's the same. I mean, but in the equation down, you wrote negative 3. Or is it x minus x1?
No, it's x minus x1.
That's why, right?
Yeah. It's x minus the x coordinate, which is 3. Had it been negative 3, it would have become plus 3. Minus minus would have made it plus. Okay. Achha, here's a question which I would like you guys to solve. Okay, please read the question carefully. I can't say that enough before you start solving it. All right, can I have the answer? Yeah, sure. Please go ahead if you have the answer.
So it's 4y is equal to 3x minus 18.
It's, let me check. 4y equals to 3x minus 18 is the correct answer. Okay, now I'm not going to solve the entire thing, but here's what I can do. Tell me the coordinates. Tell me the coordinates where the curve crosses the x-axis.
6, 0.
So you plug in y equals to 0. That means 0 equals to 3 plus 12 over 2 minus x. Then when you solve it, you get x equals to 6. Okay, so 6, 0. Then tell me the dy by dx. Tell me what dy by dx looks like.
So it's 12 upon minus x plus 2 whole square.
12 upon, shouldn't it be minus 12? Minus 12 over 2 minus x, the whole thing square. Yep, it should be minus 12. Because when you multiply it by the differential of 2 minus x, you multiply it by minus 1. So this is what dy by dx looks like. Okay, and then you plug in x as 6, you have the gradient, and then you find out the y coordinate. You already have the y coordinate, so that's it. You put the information together and find out the equation. Okay, so here's another question. Yeah.
How will it be minus 12?
How will it be minus 12? Yeah, sure, I can explain. So here's what we do. First, we write it nicely so we can differentiate it. 3 plus 12 into 2 minus x to the power minus 1. I think you're right. It's going to be positive 12. Yeah, it's going to be positive 12. Yeah, sorry. Never mind what I said. It's positive 12. My bad. It will be minus 12, but then eventually it will become plus 12. Okay. Sorry about that. Now, do this question. It's a 5-mark question, not because it's difficult. It's a 5-mark question because there's a lot of working that is required. Okay, so just because a question is 5 marks does not immediately necessarily mean that it's going to be a difficult one. Okay, looks like we have some answers. I heard the timer running also. You guys have... Well, time's almost up anyway. So I'll write down the correct answer. You guys can cross-check, see if it's right or not. Just a minute. It's y equals to 4x minus 12. Y equals to 4x minus 12 is the correct answer. So again, I hope everyone is getting the correct answer. Y equals to 4x minus 12. So I'm not going to solve the entire question. I'll just do bits and pieces of it. First, you differentiate, but before you differentiate, you got to make sure that you've written it nicely. So 2 into 3x plus 4 to the power half minus x. Then when you differentiate it, here's what this becomes. 2 gets multiplied by half, so that's 1, into 3x plus 4 to the power half minus 1, so that means minus half minus 1. Okay, now you plug in x equals to 4. Before you do that, you might want to write it nicely. So 1 over square root of 3x plus 4 minus 1. So if you plug in 4, you have 1 over square root of 16, which is 4, minus 1. So that's going to be minus 3 upon 4. Now do keep in mind, you have to find out the equation of normal. What you have is the gradient of tangent.
I'm sorry.
Bolo bolo.
You must have said you didn't differentiate the thing in the
Oh yeah, multiplied by 3 also. Sorry. So when you multiply it by 3, so it's going to be 3. So 3 upon 4 minus 1. So that's going to be minus 1 upon 4. Yeah, thank you once again. Now the gradient of normal is going to be the negative reciprocal of minus 1 upon 4, which is 4. And you already have the point. That's 4 comma 4 as well. So put this all together. Y minus... Khair, I've solved the entire thing. Now all you got to do is form an equation using the information below. Okay, so we are going to do one more question of equation of tangent and normal. This is what I had in mind for today. I don't plan on starting a new topic today. That we're going to do tomorrow, inshallah. Please remember, tomorrow we have an extra class, most likely the same time. If there's a change, I'll let you guys know, but most very likely it's going to be at the same time as today. So yeah, tomorrow we'll do stationary point. Okay, and right now we still have, I would still like you guys to solve one more question, and then that would be it. In the coming week, inshallah, the plan is to finish differentiation, and within the same month, plan is to finish integration as well. And with that, all of P1. You will differentiate inside the bracket. First, you'll differentiate the power, then you'll multiply by the differential of the expression inside the bracket. Tomorrow we will do applications of differentiation, which part of it falls under normal differentiation and part of it falls in further differentiation. Okay. Yes, M1 inshallah as soon as February starts. In February we will be doing M1 and S1 side by side. Two y minus x. Let me check if that's the correct answer. Two y equals to x, yeah. 2y equals to x or y equals to half x. Yeah, same thing. 2y equals to x, y equals to half x, same thing. Okay. Okay, do part B now. Okay, so I'll write down the answer. It's minus 1 upon 4. Okay, you're just supposed to find out the x coordinate, so minus 1 upon 4 is the final answer. Okay, notice how it says meets the curve again. So chances are when you solve it, when you solve it simultaneously, you will get one value of x as 1. That's not the value that you have to give. You have to give the other value, which is minus 1 upon 4. Okay, so I will stop here. Okay, with this, we are done with equation of tangent and normal. We did the concept in the last class, but that wasn't enough, so I thought we'll keep another class for practice questions. So we've done that today. Now I will give you guys some homework, so make sure that you guys complete the homework. It's important that you do it because this concept requires a lot of practice. Yes, someone saying something?
Yes, say for the part B, I'm only getting 1. What could be the reason?
Okay, can you tell me the equation that you're solving?
So yes, it's the equation I'm solving simultaneously is the one is the equation of the curve and the other is 2y is equal to x. So y is equal to half x. Then I substituted y as half x and then tried to solve it, and so that I'm only getting 1.
So this is what you're going to get. 1 upon 2 into 4x minus 3 equals to x upon 2. When you cross multiply, you will get, in fact, you can cross out these two. And then if you cross multiply, so you get 4x square minus 3x equals to 1. Then shift all the terms over to the left hand side. 4x square minus 3x minus 1 equals to 0. This is what you should get.
My god, I made a big blind. Okay.
Okay. Khair. So when you solve this, you get 1, and the other value should be minus 1 upon 4. This is the value that you need. Okay, so I'll stop here. Like I said, I will see you guys inshallah tomorrow, 4 p.m. I will announce in the group in case there is a change. In any case, I'll announce in the group. I'll confirm in the group as well. So yeah, see you guys tomorrow. We'll pick up from where we left off. So take care, everyone. Allah Hafiz.